So now we are going to discuss about the principles of vermicomposting. Many people know that what is vermicomposting and how it is converted as a vermicast, and then what is the uses of vermicompost and everything. Though despite we are going to discuss one by one. Okay. The vermicomposting, it is a science of manufacturing compost. The earthworms that are inhabited to the soil get their nutrition from engulfing biomass, and the digested biomass is excreted. So forming like a material known as vermicompost. As you know well, vermicompost means any material that is biomass indigested or digested to vermicompost that is excreted from earthworms. That is commonly called vermicompost. This is a natural process whereby earthworms waste material into value-added products. And another is the compost produced in this green process is popularly used as a natural fertilizer for enhancing plant growth and developments. These all processes made by earthworms. So before that, earthworm belongs to the phylum Annelida and subclass Oligochaete. The aim of vermicomposting is manufacturing and generating organic manure because that greater quality to enrich the soil nutrients. By using this vermicompost or by using these materials, an organically rich manure made to grow nutritious plants. The first and foremost thing, the principles of vermicompost is a natural and aerobic process. That means presence of oxygens that uses earth to convert organic waste into natural fertilizers. These earthworm heat materials excrete as vermicast, which are rich in minerals, nutrients, and also it contains some enzymes, plant growth hormones, etc. This vermicast improves the soil quality, and it also improves soil physical and chemical properties. Before that, we should know the area of vermicomposting using in India. In India, how much area under vermicomposting? It is difficult to find a recent and reliable area. It estimates of vermicompost coverage. Anyhow, according to the National Center of Organic Farming, that is NCOF, the total agricultural land where vermicompost is practiced around 3.5 hectares, a million hectares, 3.5 million hectares covering under 19 states. Whereas we are having 142 million hectares under arable area. Among the 142 areas, the 3.5 million hectares are covering under vermicomposting areas. At what farm size is vermicomposting practiced? According to some of the stakeholder consultant reviewed that vermicompost is practiced mainly by small and marginal farmers in all topographies, in both rural as well as urban areas. Why large landholding farmers are not used? Because they are less convinced about using vermicompost due to quick result given by chemical fertilizer in terms of crop yield and nutrients. So that is why most of the large landholding farmers are not means less convinced about vermicomposting. That's why the small and marginal farmers are using vermicompost these days. Then how many farmers are in India are practiced vermicomposting? This is also, there is no information on the number of farmers adopting it, but some stakeholders consulted estimated that 1.5 million farmers are practicing vermicomposting. This information is given by Council of Energy, Environment and Water, 2021. Then where India is vermicomposting prevalent, you see the figures. It shows almost in many states are using vermicomposting. Among the states, Assam gives highest production of vermicomposting, then Maharashtra, then Madhya Pradesh and Karnataka. You see, Assam gave 98 lakh metric tons per annual production of vermicompost, followed by Maharashtra and Madhya Pradesh, then Karnataka. These states are with the highest level of productions when compared to other states. Some of the states like Ladakh, Jammu Kashmir, Haryana, and other Jharkhand, some part of Meghalaya, Mizoram, some northern states, they are not producing any vermicompost. But among the states, Assam is the leading producer of the vermicompost areas. Then why vermicomposting? The worms do the work for us, because it is a aerator. The worms added oxygen for all the beneficial microorganisms. It is a turner. Worms work throughout the material. It is a mixer. It moves all kind of organisms and nutrients throughout the compost. And
Recording stopped.
it is a pathogen controller. Worms ignite and render useless the bad guys. It is an accelerator. It can eat up to all their weight per day, but yeah,
Recording
5
in
into 8-inch
progress.
large scale flow through system. It can produce 100 lbc of food scraps per day, and it will produce 78 to 80 lbs of casting per day. It heats 100 lbs, but it produced 78 to 80 lbs casting per day. Then it is a screener. Worm eats the bedding material and feed and turn into the rich spoil product. So always it is working for us. This vermicompost, that earthworm is always working for us. So this is the simple process of vermicompost technology. So these are all the raw materials which we are used, and release the earthworms into the raw materials that earthworm producing vermicompost. Then vermicompost we are going to apply into the soil, that the soil produced this type of crops. So the soils adding this type of improvements, and the crop gives this type of developments. So these all process made by earthworms. So before that, we should know about earthworm. Many have known about earthworm, but a few things want to discuss about in this forum. Earthworms are hermaphrodite. It means it both the male and the female organs in one individual, because the one individual worm has both organs, female as well as male. It wideband cytellum secretes mucus after mating. The mating process happened in the same portions itself. That sperm from another worm is stored there. One organs released a sperm into another organs that are stored in the same worms. After that, it produces eggs. That eggs moved to digestive organisms. These are where the cocoons are released. These cocoons almost 1/8 inch longs. These cocoons 1/8 inch long. After that, that cocoons after 3 weeks, 2 or more baby worms will hatch, which are whitish, half to 1 inch long size. It makes that small baby worms into produced into big earthworms. It takes 4 to 5 weeks, almost 1 month it takes to produce big worms. The earthworms always breathes through skin. The food is ingested through mouth, passes through, gushed into intestine for digestion, and then what left is eliminated as a vermicompost. This eliminated part, this eliminated part of that vermicompost, that product released in their anus, that product we used as a vermicast. It contains all the enzymes and the nutrients. So what are all the species which is mostly used for vermicomposting? There are 5 species. One is Eisenia foetida. This is commonly called red worm, or you can call it a brandling worm, panfish worm, road worm, tiger worm, red wingler worm, etc. It is a species of earthworm adapted to decaying organic material. This Eisenia foetida is used for vermicomposting of both domestic and industrial organic waste. Then next one is Amynthus diffringens. This is native to East Asia. You can say this is a snake earthworm, which is the longest, means lengthiest earthworm. The reproductive, this is rapidly or much more active and have a more voracious appetite. This rapid life cycle and ability to reproduce asexually gives them a competitive edge over native organisms. The next one is Eudrilus eugenia. Many of you know this one. This is African earthworm. This is African, you can say an African night crawler. It is an earthworm species native to tropical West Africa and now widespread into warm regions under vermicompost, because this is highly suitable for tropical and subtropical regions. It is an excellent source of protein. So that's why this worms mainly used for pharmaceutical potentials. Next, another one is Pyreonyx excavators, commonly called blue earthworm. This is commercially produced earthworm. These popular names for this species including composting worms, blues, or Indian blues. This species is marked for its ability to create fine worm casting quickly, because it makes vermicompost very shortly and fine quality vermicast. Next one is Lumbricus rubellus. This is redhead worm. It is a species of earthworm that is related to Lumbricus terrestris. It is usually reddish brown or reddish violet, iridescent dorsally and pale yellow vertically. You see the pictures of this worm. Their native distributions was mainland Europe and the British Isles, but they have currently spread worldwide in suitable habitats. Among the spice species, in India, there are three species are commonly and successfully used. One is Pyrenex excavatus. It is a native species of India. Then Aecinia foetida. This is exotic species that have colonized many ecosystems. Another one is Euryalus eugenia. This is also exotic species, but largely confines to experimental setup. Most of the peoples used this Pyrenex excavatus. But earthworms are three stages. One is epigeek, endogeek, and anesis. It means the earthworms is how far it is going. Some earthworms are feeding in surface feeder. Some earthworms are going up to means some make it furrows and some deeper layer. Another one is it goes deeper than deeper. The first epigeek means it's a feed on the partially decomposed litter on the soil surface and do not make any furrows. So this is epigeek. Then epigeek. Another one is endogeek. It means the feeds on mineral soil of deeper horizon and they rarely make permanent furrows. This species is making permanent furrows. This species is making permanent furrows. And the anesis means they make deeper furrow and drag organic matter to the deeper soil to the soil. And this is the simple process, step-by-step process of vermicomposting. So initially we have to make a bottom make of 6 inches cemented wall to prevent escape of earthworm to the ground soil. Then this is the simple process to make vermicompost preparations. Then partially decomposed composed materials we have to add for vermicompost. In generally, we said three part. One is pre-digest part, and digest part, and the post-digest part. Pre-digest part means the material which is used to used for vermicomposting. When before releasing of earthworm, we used pre-digest material. That is partially decomposed material. The next digest part means where when we are going to release earthworms, that portion is digest part. Then after vermicast preparations, that part is post-digest part. So cow dung, 20 to 25 days old, that is completely decomposed. That is partially decomposed materials we have to use for vermicomposting. Then beds are kept as such as 15 to 20 days to cool down. Then after that, we have to sprinkle the water, let the compostable matter cool down. After that, we have to release the earthworm 2 to 2.5 kgs for 135 kg pit with vermicompost. Then spread another layer of cow dung, the same 15 to 20 days old, initially decomposed, then 10 to 15 inches height. Then add other biodegradable waste like plant materials and dry leaves, etc. Then cover the vermicompost with jute to prevent entry of ants, lizards, snakes, and other predators, and to maintain the moisture of vermicompost. After that, we have to sprinkle the water to maintain the moisture. Then immediately it's get ready to 70 to 80 days after these preparations. So this is small procedures. Before that, how we are going to prepare a cultural bed. So cultural bed, we have to prepare the base layers of vermi bed comprises of broken bricks. This base materials we have to put some broken bricks, then add some part of sand particles. These two add as a filtering agents. So filtering agents, and also it is for proper drainage. These two materials are used. Then after that, we have to add loamy soils up to the height of 15 centimeter, which was moistened. The earthworms, Aecinia foetida, or other mixed cultures. Always we have to release mixed cultures of earthworms were inoculated into this layer. Then lumps of fresh and dry cattle dung were scattered over the soil. This is lumps of fresh and dry cattle ducks were scattered over the soils. Then after that, we have to cover with the dry grass clippings, straw up to 10 centimeter thickness. This is how we have to prepare cultural bed preparations. Then materials for preparations of a vermicompost. So some of the biodegradable waste, mostly for vermicompost, we have to use biodegradable waste. One is crop residue. So this is for crop residues and weed biomass. Then vegetable waste. This is collecting from a vegetable market. And then leaf litters. We have to collect where the number of trees available. There we can collect leaf litters. Then hostile refuses. In this is hostile refuses. Maybe both degradable and non-degradable materials are present there. So we have to collect only for degradable material. Then waste from agro industries, then biodegradable portions of urban and rural waste. Then urban and rural waste, this is also mixed with non-degradable materials, so we have to separate it. Then another one material, that is farmyard manure. So these all are materials for preparation of vermicompost. Then next types of vermicomposting. So we have to collect material. There are two types. One is large scale vermicomposting, another one is small scale vermicomposting. In large scale, it is carried out on commercial scale, it producing between 15 to 100 tons organic waste per year. Whereas in small scale vermicomposting, a farmer can collect 5 to 10 tons of vermicompost per year when vermicomposting is small scale is suitable for personal needs. Those who are having small land holdings or some pot plantings, they can produce for their small scale vermicomposting. If the persons one who like to scale in large scale, they can go for commercial scale, that is large scale vermicomposting. They can make 50 to 100 tons of organic waste per year. Then production of vermicompost in large scales, always we have to make a thatched roof shed in unpaved, in erected in east-west directions, because we have to avoid always sunlight, direct to sunlight. And then shed area should be 12 feet into 12 feet. This is sufficient to accommodate 3 vermi beds of 10 into 3 feet, each having 1 feet space in between for the treatment of 9 to 12 quintals of per cycle in 40 to 45 days. The length of shed can be increased or decreased depending upon the quantity of degradable waste that we used. It is converted into availability of spaces. The height of thatched roof is kept at 8 feet from the center and 6 feet from the sides, because always the vermicompost unit should be 100% fully aerations. The base of site is raised at least 6 to 9 inches above the ground to keep from flooding during the rain areas. So this is the model vermicompost unit in large scale. So always we have to keep 8 feet height of the center area, then 6 feet height of both the sides and the sides. So we have to give 1 feet distance from one pit to another pit. So this is the model for large scale production of vermicomposting. Yeah. Then how vermibed is prepared. The vermibeds are laid over the raised ground by putting a layer of 4 feet to 6 feet of biodegradable agriculture residues, that is dried leaves, straw, sugarcane trash, soaking with waters. This is followed by 1 feet layer of farmyard manure we have to add. Then we have to release the earthworms at the rate of 1 to 1.5 kg per bed. It means 1 to 1.5 kg means it almost comes 10,000 to 15,000 numbers. Then frequency and the limits of loading, the waste can vary depending upon the cost of the users. Daily, they can feed 2 feet per bed per day. So then only they can collect every 40 to 45 days interval. So this is open bed. This is with the controlled conditions. Then some people are preparing for concrete tank. The vermicompost can also be prepared in concrete tanks with the size of 10 feet into 3 feet into 3 feet. The available bio-waste are collected and are heaped under sun for 7 to 10 days. The layer of chopped wheat biomass and partially decomposed cow dung, that is 1 to 2 feet, we have to add at the bottom. Then place the chopped wheat biomass and the partially decomposed cow dungs 50 to 50 wise in the tank up to 2.5 feet we have to add. Then release 2 to 3 kg earthworm per ton of biomass or 100 worms per square feet area. Then after that, we have to place wire net and bamboo net or banana leaves over the tank to protect from birds, ants, and some other enemies are entered into the tank. So different persons are preparing different size of tanks. Suppose some people are using in small scale, they can prepare under the tree, and some people are they're using their kitchen garden, means the kitchen waste to prepare vermicompost for their kitchen gardens. So this is small scale level. This is commercial unit of vermicompost preparations. Those who are preparing in large scale, they can put into open space, but it needs uh, higher maintenance, because here the problem is ant, mite, snakes, rodents. These are all the problems with this. But if they give higher maintenance, they can produce large quantity of vermicompost. So mainly those who are doing commercial, this type of roof they are making. Then methods of vermicomposting, there are 4 methods. Among the 4, mainly 2 methods are popular. One is bed method, another one is pit method. So this is bed method. In generally, they are using 6 by 2 by 2 feet. Composting is done in the pakka or kacha floor. This approach is simple to use. Another one is pit method. This is pit method, and this is heap method. This is bin method. Among the 4, only pit method and heap methods are popular in the means popular in India. Composting in pits that are 5 into 5 into 3 feet in size and made of cement in the pit methods. After that, we have to cover some touch grass or any dry leaves to protect on the roof. This is not favor in since it produces more waste as poor aerations, and also cost is also more this method. Another one is nutrient profile of vermicompost and farm-made manure. When compared to farm-made manure, the vermicompost has highest percentage of nitrogen, phosphorus, and potash, but calcium a little bit higher in farm-made manure when compared to vermicompost. So this data I have taken from Muhammad Ashraf Islam in 2016. They have published some data. Another one is comparative nutrient content of different organic manure. When compared to other organic matter like farm-made manure, compost, pig dung, biogas slurry, cow dung, mustard cake, neem cake, the vermicompost has highest nitrogen, phosphorus, and a potash percentage. So this is also taken from the same articles. Then advantages of vermicompost. Vermicompost is an eco-friendly and biofertilizer. You know very well. It is also rich in beneficial microflora such as nitrogen fixer, phosphorus solubilizer, and cellulose decomposer. It is also rich in micronutrients than other compost. It enhances the decomposition of organic matter in soil, and also in mixtures incidence of pest and disease in crop. It's minimized incidence of pest and disease in crop, and also it improves soil structure, aeration, texture of soil. It also improves water holding capacity. It promotes better root growth and nutrient absorptions, and also it contains valuable vitamins, enzymes, hormones like auxin, gibberellins, cytokinins, etc. It improves the nutrient status of both macronutrient as well as micronutrients. See, the picture shows it suppresses the disease and insect attack, and also it controls the Fusarium moniliform and Aproarium modicilla, and also it is enriched with auxin, gibberellic acid, cytokinin, humic acid, vitamins, etc. It also improves plant adaptations to abiotic stress, and also it increases the activity of soil enzymes, break down the organic waste materials. Also, vermicompost enhances biodiversity by promoting the beneficial microbes. 20 times increase the microbial activity in soils. When we apply vermicompost, it improves 20 times increases. Then it increases the long-term nutrients like NPK, calcium, magnesium, sulfurs, and other micronutrients, and also it increases soil aerations, then maintain soil temperatures. So these are all the advantages or benefits by using vermicompost. Some of the precautions we have to take when we prepare vermibud or vermicompost, we should be protected from direct sunlight. The worms should be protected from ants, rats, and birds. The vermibeds are covered with jute mat or banana leaves to protect birds and earthworms. The waste is turned upside down fortnightly without disturbing the base layer. Then sprinkling of water should be once in 3 to 4 days. Because if you maintain regular moisture, then only the worms can survive. Because always earthworms are active in between 10 to 32 degrees Celsius. Then only this process makes faster than compost. The black granular crumbly powder, when it comes black granular crumbly powder on the top of the vermi bed, this situation is ready to harvest. And the watering is stopped 5 days before the harvest, and the compost is collected from the top without disturbing the lower layers. Heaping can be done under shade, and the sieving may also be the separate, and the earthworm and the cocoon. The first harvesting is ready after 2 months. After 2 months of the bed preparation, the subsequent harvest may be after 6 weeks of loading. Then granular compost formations after 40 to 45 days at the surface area. It indicates that the compost is ready for harvesting, which can be top scrapping layer waste from the top of the tank. Some of the limitations of vermicompost productions, because it is time-taking process, it requires almost 5 to 6 months of decomposing the organic waste to prepare vermicompost. In comparison to the traditional composting process, vermicompost requires higher maintenance, and then vermicompost may harbor pest and disease as a temperature. Vermicomposting pit have to cool enough to support earthworms. I already told you that we have to sprinkle the water to maintain the moisture between 35 to 45% always, because the earthworm, if it is exceed 35 degrees Celsius, the earthworm cannot survive. If it is lower than 10 degree also, it cannot survive. So we have to maintain the temperature in the pit. So every 3 to 4 days once, we have to sprinkle the water to maintain moisture. So after preparation of vermicompost, we use it in general for cereal and pulses vegetables crop at the rate of 2 tons per acre. In case of fruit crops, we can use 2 to 3 kg per plants. If it is more than 3-year-old fruit crops, we can use 2 to 3 kg per plant in general. How to protect worms? The one way to protect the worm is to create a barrier that the ant won't process. If ant enters into the pit or bin, definitely the earthworms get affected. Or you can use diatomaceous earth. It is a repellent. It's capable of killing ant, which can be easily spread around your bins. Another one is white chalk-like powder. This is derived from fossilized shells of diatom and ancient marine algae. So this is the methods which we can use to protect our worms from their enemies. Some of the research findings I have attached here. Many researchers are undergoing, and some research findings are already published. The Muhammad et al. 2020, they said that they assured that the application of vermicompost reduced soil SDT and also produced macro and micronutrient content, that is NPK, secondary nutrients of magnesium, calcium, sulfur, and some micronutrients of iron, zinc, boron, and aluminum in the soil. And another Nigerian and Shauri 2020, they are also observed that when they apply vermicompost, the banana leaf content has increased, and increased of chlorophyll, nitrogen, phosphorus, and potassium. And similarly, chlorophyll A also increased in plant grown in sugarcane compost at all concentrations used compost control plants. So then Hassan et al. 2022 also said that when using vermicompost combined with vermiculite and sand of 33.3% each, recorded the best result for most vegetative growth of studied parameters in banana. So these are all the findings which I have found. And another one is effect of vermicompost on plant growth development. So when we apply 100% vermicompost, and when we apply 100% recommended dose of fertilizers, it gives root length, shoot length, leaf area index is lower than when we do approaches of integrated approach, that is 50% of vermicompost and 50% of inorganic fertilizers of NPK. So always we want to go for integrated approach, then it increase root length, shoot length, and leaf area index. This is Manivan and et al. 2019, they said like that. So these are all the research is happened. So overall, coming to the conclusion of my presentations, the earthworms are helpful in industrial waste into valuable products. So vermicompost produced from waste could be applied to crop as a source of plant nutrients. So still there are some gaps in vermicomposting research. because most of the studies are carried out in controlled conditions in laboratory scale. So we need to improve large scale of vermicomposting research to give better result. So some of the one of the success stories in Tamil Nadu, one of the agri graduate, it's called Gopi. He's having one industry that is RD agro products in near Chennai. It is around 250 kilometers, 300 kilometers far from Chennai, because he is doing successfully vermicomposting. Every year, he is producing more than 6,000 tons of vermicompost by using different raw materials like sugarcane bagasse, then lignite ash, and coir pith. Then some other materials they are using. Every year they are producing 6,000 tons of vermicompost. Because many people are thinking, if I am producing vermicomposting, how I am going to sell? But he is not focusing to the farmers or some other persons. He is always focusing to fertilizer company, because many fertilizer companies are having many sales managers. They are moving here and there, and they are getting sales. They are getting means marketings. So these persons always focusing to that fertilizer company is ordering, means he is selling to fertilizer company. They are marketing his product. So is every year he is selling 6,000 tons. So in his farm only, I'm taken this photo. So this is open method under the coconut. So you see how is heaping, and also automatic water sprinkler is how installed in this unit. So some partially decomposed cow dung we have to use always. So this is the press mud compost. This material also can use for vermicompost preparations. Then lignite ash. So these are all the materials is using this unit. So thank you. So uh, this is thanks to all those who are presenting here. If any queries, can ask me.